If you use Wireshark, you must be very familiar with the normal Ethernet frame. For example, on the screen, you can see this Linux terminal. If I check the IP address, it's .1.9. Then from the right side, Linux number 2, let me ping it. Just ping it once. Before doing that, in the left side Wireshark, let me start capturing. As you can see, I already set the display filter to ICMP. So then I'm ready to ping the Linux number 1 from Linux number 2. Let me do it. Okay, 2 frames are captured, 1 request, 1 reply. Stop capturing. Let's check this example frame. So you can see there's a section, it's called Ethernet. Then you see 3 parts, destination, source, and type. As indicated on the diagram, the first 6 bytes is for destination MAC address, then followed by 6 bytes for source MAC address. The third field is 2 bytes for the type. So you can see for this example, the type is 0800, which means IPv4. Then, of course, followed by the data and the CRC field. So this is pretty simple, pretty normal Ethernet frame. I use UniFi network devices. The VLAN 1 is for default network. So of course, I don't see VLAN information in this frame as expected because it's untagged. But you may know there's also VLAN Ethernet frame. It's almost identical to the normal Ethernet frame, just has one additional part. It's 4 bytes. It can break down to 4 fields, 2 bytes hard-coded. It has value 8100, which means it's VLAN frame. Then it has a priority. Normally we see 0. Then it has a indicator. It's hard-coded to 0 for Ethernet network. Then the fourth field is the most important information for us. That's the VLAN ID. But it's not that easy to see this VLAN tag information in Wireshark. So in this video, let's talk about it. This is my lab environment. I use a UniFi switch, the USW Pro Max switch. Let me show you the port information. As I marked on the diagram, the 3 Linux virtual machines, they are connected to 3 different physical ports on the switch, the port 17, 21, and 24. If I show you one of them, if you check the port VLAN settings, they have the native VLAN set to default network, and for tagged VLAN set to allow all. This is the switch side setting. And for the 3 Linux virtual machines, I run them using Proxmox. For the Linux number 2 and number 3, they are very simple. They only have one network device connect to a particular port on the switch. For the first Linux machine, I set up 2 network devices for the virtual machine, but they are using the same physical port. So let me show you. This virtual machine is for the Linux number 1. So you can see for hardware, you see 2 network devices, right? For this net 0, you can see it's using this port file, and I don't have VLAN tag set. But for the second network device, it's using the same port file, but I set it to VLAN tag 10. So from this Linux virtual machine perspective, it has 2 network devices by default. And for the first network device, it's using VLAN 1, the default network. The second network device is VLAN 10. And then for this Linux number 2 and number 3, I already set them to VLAN default and VLAN 10. So this is the current lab environment setting. Then let me show you the problem if you try to capture VLAN tag using Wireshark. So in the beginning of the video, in fact, what I did was for default network, the VLAN 1, which is untagged. If I ping Linux number 1 from Linux number 2, in Wireshark, we don't see VLAN tag. It was expected because for this case, the VLAN 1 is untagged. So that's why we don't see VLAN tag. But this time, let me try to ping Linux number 1 from Linux number 3. So here on the screen, you see the Linux number 3, right? If I check the IP address, is .10 something, so it is in VLAN 10. For Linux number 1, by default, if you use Network Manager to manage your network, it only has one active network interface. So let me switch on the second one, then close it. Now if I check the IP address again, you can see it's changed. Now it has the .10 subnet IP address, which means it is in VLAN 10. Okay, so now let me try to ping Linux number 1 from Linux number 3. So from Wireshark, let me start capturing. Then from the Linux number 3, let me ping Linux number 1. Okay, ping it once. 2 frames are captured. If I check this frame, you can see the Ethernet section. The type is still IPv4. If this frame is a VLAN frame, here for this type, I expect to see 8100, but instead now I see 0800, which means this frame we are seeing now, which is captured by Wireshark, is not a VLAN frame because we don't see the VLAN tag. Now we have a problem. We know for sure this network traffic from Linux number 3 to Linux number 1 is done on VLAN 10. But from Wireshark, the captured frame doesn't have VLAN information. Why is that? We will answer the question later. Let me try another way to add a new network interface in the Linux number 1. Let's see whether in that way the Wireshark works. For Linux number 1, let me add a new network interface from the operating system level. This particular one, I'm going to use the same network device, but create a new interface for VLAN 10. After it's done, we will end up with 3 network interfaces from the OS level. Let me show the current IP link. You can see both network devices, they are up. But we are using Linux Network Manager to manage the network. So only this ENS19 is up and it has IP address. So let me manually manage my network so that I can have both network devices up and have IP addresses. Let me run this command to manually set the IP address for the ENS18 network device. Okay, then if I show the IP address again, now you can see both network devices are active and they both have IP address, right? Then let me create a third link. It's based on the existing network device. It's just a OS level network interface based on the same hardware. So let me first create a new link based on the same ENS18, the existing one. Give it this name. The .10 means it's for VLAN 10, and then the type is VLAN, and the VLAN ID is 10. Okay, now if I run IP link, I can see this ENS18.10 already, but you can see the state is down, and of course it doesn't have IP address yet. Then next, let me give it a static IP address in subnet 10. Of course, the device should be ENS18.10. Okay, then I need to bring up this new interface. I simply run IP link, set this new interface up. So now if I show you the IP address one more time, now you can see I have the new device showing here and it has the IP address I want. So now we are done with this new network interface creation from the OS level. At this moment, this Linux has 3 network interfaces. One for default network, the other 2 for VLAN 10. But the 2 VLAN 10 interfaces, they have different IP addresses for sure. At this moment, if I run 3 Wiresharks trying to capture frames for these 3 interfaces respectively, let's see what's the result. In Linux number 1, I already launched 3 Wireshark sessions. Start capturing. For the first one, capture the default network for ENS18. The second window capture the ENS19 for VLAN 10. The third window capture the ENS18.10, the one we manually created on the OS level. It is also for VLAN 10. Okay, so then from the Linux number 2, let me ping Linux number 1's default network IP address. In the captured frame, if we expand the Ethernet section, the type is not VLAN as expected because this is untagged. Okay, then from Linux number 3, let me ping the VLAN 10 IP address for the ENS19 network interface in Linux number 1. If I check both of them, you can see the Ethernet, they are all IPv4. They are not VLAN 10, but we expect these two frames to be VLAN 10 Ethernet frame, right? Let me ping Linux number 1 from Linux number 3, but this time ping the IP address for the interface which we manually created. If you check the captured frames, you will see the same thing. They are not VLAN frames. However, you may notice in the very first Wireshark session, it is supposed to be capturing the default network traffic, right? But you can see this ping we did on VLAN 10 as well. And then if we look into the details, see the Ethernet section, the type, it has value 8100, and you can see the type is VLAN. All of a sudden, instead of seeing the VLAN frames in the other two Wireshark sessions, we see them in the first Wireshark session. Then if we compare the diagram for VLAN frame, we can understand for the first, the TPID field, it has the hard-coded 8100. And then if we expand the VLAN section, you can see the priority is 0, the indicator is 0, and then the VLAN ID is 10. This is exactly what we want to see. This frame is a VLAN frame. Let me explain what happened. For the second and third Wireshark sessions, they capture this VLAN interface and this VLAN interface. Depending on the operating system and the network interface card driver, the behavior may not be the same, but for Linux, for this Proxmox, the way it works is for the second Wireshark, it captured this particular network device, right? This one is a virtual one supported within Proxmox, and it is based on this physical part. And Proxmox runs a driver for this network device. So that driver will forward the packets to the Linux after it removes the VLAN tag. That's why in the second Wireshark, we cannot see the VLAN tag. Then for the third Wireshark, it's capturing this network interface, which we manually created within the OS, right? So the Linux runs a driver for this interface. That driver will remove the VLAN tag before it sends the packet to the host, to the Wireshark. That's why from the third Wireshark, we also cannot see the VLAN tag. But why for the first Wireshark, which is capturing this network interface, we are able to see the VLAN tag for VLAN 10? It's because of two reasons. First reason, the part is for default network. And we said the native VLAN is default network, allow all for tagged VLAN. So that's why the tagged packet will also flow through this part, even though this particular network interface is not interested in other VLAN's information, but the frames will be handled by this part, the physical part anyway. That's reason number one. Reason number two, we are running Proxmox, and from Proxmox, we can set the part in promiscuous mode. We will be able to see the packets in Wireshark even though the packet is not destined to this network interface. So that's why in the three Wireshark sessions, we see different results for VLAN 10 frame. I hope it's clear. In this way, you are able to see VLAN 10 information if your network configuration is like this. But this situation doesn't apply to general setup. You may not run your Linux within virtual machine, right? Or you may not use the same physical part. Then in general situation, how you can see VLAN tag, let's explore another option. As we just saw it in action, if you run Wireshark within the host, you may not be able to see the VLAN tag because network interface drivers already removed the VLAN tag before it sends the packet to your application or to Wireshark. To work around that, we can capture the packet from the switch level just to eliminate the effect from the operating system or from the network card driver. So in this way, for port 9, I connect a dedicated Wireshark virtual machine from UniFi network controller. You can see for port 9, I set it to mirroring port 17. Port 17 is connected with the Linux number 1, right? So in this way, we will see the original packets forwarded by the switch before it reaches the operating system. So let's see what will happen this time. In the Wireshark, let me start capturing. Then from Linux number 2, let me ping Linux number 1. It captured packets. If we look into them, for this frame, the type is not VLAN because it's default network, and we set this part in the way so that this packet is supposed to be untagged. So we are good with this one, right? Then from Linux number 3, let me ping this ENS 19 IP address, which is for VLAN 10. Okay, something's captured. If we check the details, see, this time we see the VLAN tag. So even though we are pinging this IP address, we are able to see the VLAN tag from the switch level. Then from Linux number 3, let me ping another IP address, which is for the manually created operating system level network interface, the ENS 18.10. Okay, let's see what's captured. We see VLAN tag, and it's for VLAN 10. So in this way, no matter how you run your virtual machine or physical machine, no matter what's your network card driver, no matter what's the operating system, you will be guaranteed to see the VLAN tag if you run Wireshark from the switch level. This ends the video. Thanks for watching.